have taken the integral of sine and cosine a few other trigonometric functions, but there are still a few trigonometric functions that we can actually find integrals of. At the end of this lesson, you'll be able to evaluate an integral involving a basic trigonometric function. All right, let's take a look at evaluating the integral of tangent u du. If you recall, we do not have a formula for tangent. We do for sine and cosine and some other ones, but definitely not tangent. If it said secant tangent, I do, but I don't have any for this one. So I'm just going to show you the long way, first of all, of getting this integral. First of all, I know that tangent is equal to sine over cosine, so I'm going to turn this into sine of u over cosine of u. And then from here, since I have a denominator, I'm going to do what we've been doing a little bit earlier. I'm going to let our next u be the denominator. So it's going to get a little bit confusing here. So I'm going to have u is equal to the cosine of u, which means my du would equal, the derivative of cosine is negative sine u du. You will notice that I do have sine u du, I'm just missing the negative. So negative goes on the inside, negative goes on the outside. So if I were to rewrite this, I'm going to get negative, the negative sine u and the du, they all become du. And then the denominator, the cosine u, is going to become u. So from here, the derivative of the integral, of du over u is natural log, and we'll carry that negative along, of the absolute value of u. And in this case, our u is cosine u. I know that was a little bit confusing with all those u's, but there we go. That is a formula. What you're going to be doing is learning a bunch of different formulas. Notice this one, I didn't really have to memorize it. I could work it out and actually get an answer. Some of them will just be easier to actually memorize. So if you look at these ones, the integral of tangent we just found out was negative natural log, that will turn out the same way every time, of the cosine of u plus c. The cotangent is going to be very similar, but it's going to be positive natural log sine u plus c. And the workout of that would be very similar. If I had secant, what we'll end up getting as an integral is the natural log of the absolute value of secant u plus tangent u plus c. And then for cosecant, we're going to actually have negative natural log of cosecant u plus cotangent u plus c. And again, though these formulas can be derived and you can figure them out, it's usually easier to recognize that I have a formula for it and then memorize the formula. But I will leave that up to you. Alrighty, next one, it says to evaluate secant x over 3 dx. So I'm going to keep in mind that I know that the secant u du, the integral of that is going to be natural log secant u plus tangent u. So I know that there's a formula for secant, so I've got secant here. So that just means that I need to let my u be x over 3. Okay, x over 3, remember, is really just the same thing as 1/3 x. So if I take the derivative of 1/3 x, that would just give me 1/3 dx. And I notice that I have my dx, I'm missing a 1/3, so I'm going to put a 1/3 on the inside, which means I have to put a 3 on the outside. So I'm going to put a 3. I have done absolutely nothing with the secant in my substitution at all, so the secant needs to stay. X over 3 becomes my u, and then the 1/3 and the dx get to cross out and they become my du. So now from here, it's straightforward, just getting to use the formula. Bump your 3 down. The formula says the natural log of secant u, which is x over 3, plus tangent u, which is again x over 3, plus c, and then I would be done. Okay, next one. It says to evaluate the integral of the cotangent of 5x. Again, I have a formula for cotangent. The integral of the cotangent of u du is equal to natural log of the sine of u. So, recognizing that I just have a cotangent, I'm going to let my u equal 5x. And if I do that, my du, the derivative of 5x, is 5 dx. I notice that I have the dx, but I'm missing the 5, so I'll put a 5 on the inside, which means I need to put a 1/5 on the outside to undo it. So 1/5 on the outside. I have done absolutely nothing with cotangent, so the cotangent is still in my problem. The 5x was my u, and the 5 and the dx get crossed out because they were a part of du. Now from here, I just get to use the formula, but my 1/5 out front. Again, the integral of cotangent was natural log of the absolute value of the sine of u plus c, and then I'm done. So it's mostly formula recognition on this one, and then identifying the u. So hopefully now you can take the integral of some basic trigonometric functions.